Hello guys, let's begin with our new chapter, sound. In this chapter, we will be studying all the things related to sound that are required to be studied at this level. We will first see the introduction of why we are studying this chapter, then we will go on and look into production of sound. After we have learned how sound is produced, we will look into how sound waves propagate. The subparts of which includes that sound wave requires a medium to travel, sound waves are longitudinal waves, characteristics of sound waves, and speed of sound in different mediums. We will look into all of these, which will be followed by reflection of sound, which covers important topics like echo and reverberation. Then we will go into range of hearing, which has applications in ultrasound. And in the end, we will conclude this chapter with structure of human ear. So let's begin with the introduction. We hear sound from various sources like humans, birds, bells, machines, vehicles, televisions, radio sets, etc. Sound is a form of energy which produces a sensation of hearing in our ears. Other forms of energy gets converted into sound energy. Similarly, sound energy can be converted to other forms of energy. So the question arises, why are we studying this chapter? It is because sound itself is a very important form of energy. Sound is a part of our life that we can't go away with. If we look deeper into the applications of sound, it has numerous applications in terms of medicine, in terms of engineering, and others. Therefore, it is important to learn this chapter. So let's begin with production of sound. Sound can be produced using a tuning fork. What I'm trying to say is, suppose this is my tuning fork and I have a rubber drum kept next to it. Now as soon as I hit the tuning fork, it starts to vibrate. Now what happens is, through the air present in between the tuning fork and the drum, this vibration travels and reaches the drum. Now as soon as it reaches the drum, the rubber film that is present on the drum, it starts to vibrate. Now this vibration causes the sound to be produced. Sound can also be produced by plucking, scratching, rubbing, blowing, or shaking different objects. We set the objects vibrating and produce sound. Vibration means a kind of a rapid to and fro motion of an object. The sound of the human voice is produced due to the vibrations in the vocal cords that are present in the neck of humans. When a bird flaps its wings, it produces buzzing sound. Now, that were the ways how the sound is produced. Now let's see how sound propagates. The matter or substance through which sound is transmitted is called a medium. It can be solid, liquid, or gas. Sound moves through a medium from point of generation to point of listener. What the important point here is, sound requires a medium to propagate. When an object vibrates, it sets the particle of the medium around it vibrating. The particles do not travel all the way from vibrating object to the ear. What happens is, the particle that is in contact with the vibrating object first gets displaced from its equilibrium position. Due to this displacement, it exerts a force on the adjacent particle, as a result of which the adjacent particle gets displaced from its position of rest. Now after displacing the adjacent particle, the first particle comes back to its original position. This process continues in the medium till the sound reaches your ear. The disturbance created by a source of sound in the medium travels through the medium and not the particles of the medium. So what I'm trying to say is, suppose this is the source which is producing the sound, and these are the particles that are present in the medium between the source here and the listener, which is situated here. Now as soon as the source starts vibrating, it sets the particle which is adjacent to it also vibrating. Now due to this vibration, the particle which is next to it also starts vibrating, and this process continues till it reaches the listener. So what happens is these particles do not leave their position, or they do not travel from source to the listener, but instead the sound travels from source to the listener through vibrations in the medium. Now what makes sound to be a wave? A wave is a disturbance that moves through a medium when the particles of the medium set neighboring particles into motion. They in turn produce similar motion in others. The particles of the medium do not move in forward themselves, but the disturbance is carried forward. This is what happens exactly during propagation of sound in a medium. Hence, the sound can be visualized as a wave. Sound waves are characterized by the motion of particles in the medium and are called mechanical waves. Creation of alternate high pressure regions, which are also the compression regions, and low pressure regions, which are also known as the rarefaction regions, as shown in the figure here. C is denoted to be the compression region and R is denoted to be the rarefaction region. Now pressure is related to the number of particles of a medium in a given volume. More the density of the particles in the medium gives more pressure, and vice versa. Thus, propagation of sound can be visualized as propagation of density variations or pressure variations in the medium. Now let us understand what does the above paragraph tries to convey. Through this picture, we can see that when this tuning fork is set into vibrations, the particle in air that are present next to it also starts vibrating. What happens is, when the tuning fork moves in the forward direction, the particles in the air which are next to it gets compressed or form a high pressure region known as the compression region. The particles which are next to these compression region form a rarefaction region or a region of low pressure, and this continues alternatively till the point it reaches the listener. Now as soon as the fork goes back from the equilibrium position, this compression region is changed into rarefaction region, and correspondingly the rarefaction region present here is converted into a compression region, and this alternatively again carries till the listener, and hence this is how sound propagates in the medium. Now I said earlier that sound requires a medium to travel. Now we need to demonstrate why is this so. The bell jar experiment shown here is a very simple experiment which shows that sound requires medium to travel. The experimental setup of this experiment is a bell which is put inside a jar, and this jar is connected to a vacuum pump. The experiment is started by putting the bell into ringing mode. Now as soon as the bell starts ringing, the air is slowly sucked out from the jar. What is observed is sound becomes fainter as the air is pumped out of the jar. This shows sound requires a medium to travel. Now let's move on to the next topic, which is sound as longitudinal wave. Sound propagates by a series of alternate regions of compression and rarefaction, as we have seen earlier. A wave which propagates by compression and rarefaction is known as the longitudinal wave. Hence, sound wave is a longitudinal wave. What happens in longitudinal waves is, these waves, the individual particles of the medium move in a direction parallel to the direction of propagation of the disturbance. The particles do not move from one place to another, but they simply oscillate back and forth about their position of rest. Like the longitudinal waves, there are also waves which are called transverse waves. Transverse waves are those in which particles of the medium move perpendicular to the direction of propagation of disturbance. One example of transverse wave is the light wave, which is electromagnetic in nature. Light is not a mechanical wave, as particles of the medium do not vibrate, rather electric and magnetic fields that are associated with the light wave vibrates as the light propagates. We will study in detail what are light waves and what are electric and magnetic fields associated with it in higher classes. This brings us to the end of the first video in the chapter Sound. In the next video, I'll be talking about the characteristics of the sound waves. Thank you.